Hello friends, सबको नमस्ते. So today in this video we will make a flower classification using a YOLO model. My zip file, or you can say my dataset, is uploaded in a different Google account. So I have to upload my zip file from that Google account to this current Google Colab. For that, just use a share link and just copy this part and copy this part till this uh, till here and here till here. You have to copy and just paste it here. Then run this cell. You will get the zip file. First, it will connect. Let me run it again. So this is just a file. Okay. Now we have to unzip it. Okay. Just refresh it. You can get the flower classification. We have three folder: test, train, and valid. And inside the train folder, you will get a flower with the two class names, Daisy and Dandelion. Okay. Now let me install the Ultralytics, which is required to upload a YOLO model. Okay, now to upload a YOLO, pre-trained YOLO model, we have to use import YOLO from Ultralytics. Then model is equal to YOLO. We are using YOLO V8, and you can see that YOLO V8 have a different classification model like YOLO V8 and S, M, L, and X. You can see the differences have a difference in between them, have a different parameters, but mostly you look for the params, means the parameters. So number of weight which we are using is YOLO V8. We are using YOLO V8L, and the parameters inside this is 37.5 parameter, and the size on which this model is trained is 224. Okay, after loading the pre-trained model, we have to train it on a custom data set of our flower custom data set. For that, just use a model.train. Just give the data set name, and epoch will be 30, but right now it should be 5 because I already have a model which is trained on 30 epochs. So I will upload that and show the result of that model. So image size will be 224. Batches 8 means that during training, when the images is divided into batches, I want all that in each batch 8 images should be there. And this is a folder name, means when you will run this cell, the run folder will get created, and when the run folder, inside the run folder, classifier folder will be there, and inside the classifier folder, either one folder is there which whose name will be this. Inside that folder, you will get the weights folder. Inside the weight folder, you will get the weight of that particular model. Now save true. Yes, we want to save the model. Save period minus birth means we do not want to save every epoch weight file. We just want to save the best one among the epochs. Okay. Now patience 20 means early stopping, means after every 20 epoch it will see that the accuracy is increased or the loss decrease. Okay, if it is not happening, it will stop the training. Validation true, yes, because we have a validation folder also. You can see it. So now let me run this cell. Our training gets started. See here, GPU RAM is GPU memory, which is required during epoch training, means during training, and loss is a classification loss. And 160 is a batch size, you can see. Now let me explain to this. See, one thing that when you run classify the folder name which we have decided, the inside the weight file, and inside that you will get best and last. We want to use best one, so you have to give this directory to load the load the model which is trained on your custom data set, which is saved in this folder. Then the test folder, you have to get flower classification test. Now we have to make the list of all the folder name present in that particular test directory. Okay. Now I have to plot 16 images. For that, I want 4 rows and 4 columns. So plot that subplot, 4 rows and 4 column. Figure size will be 16 by 16. Now, since I have to means we have to subplots for 16 images, so I have to use for loop for 16 time. Then I have to select randomly select the folder name. Then then after selecting the folder name, I have to make I have to make a list of all the file name present in that particular folder, so that I can randomly select the file from that list. For that I have to use OLS directory, and inside that I have to make the directory. I have to give the pass the directory name. For that I have used OS path join, then test image directory, then the folder name which I have selected randomly. Now I have to create the image path. For that I have to use os path dot join, then the test image folder, then randomly select the folder name, then randomly select the file name from the image file list. After making a image path, just read the image. Or in this you can see that I have passed the image path, not the image. But either you can pass the image path or the image. After reading the image, it does not affect it does not affect the prediction. It is, and also doesn't show any error. Okay. Now after result for the prediction, for getting you can see that I am just passing the only the one image. So to get the prediction of the one image, just use the zero index value, you will get the prediction. Now let me explain you this whole thing. Print. See, I have used model dot name, which give me the information that which class ID belong to which class name. Then result, print the result, then printer result dot props. Okay, now I just want one iteration right now. You can see that training gets over, so I can easily use that model, best model. Let me run this cell. Oh, what is the problem? This directory. There is no folder dataset. Just let me run this now. See here, this model dot names give me the information that which class ID belong to which class name. So 0 belong to Daisy and 1 for Dandelion. And this now result that this variable, this result variable basically contain this information. You can see key points, name, boxes, names is the 01, uh, and all main information, basically the main prediction you can say, is stored in this props variable. Props, not props title, you can say props variable, you can say props attribute, you can say. Okay, so inside this result dot props, you can see that it's contained data tensor zero. See, we have how many classes? We have two classes, Daisy and Delilin. And see, here's 1.7529 and 9.99 is basically describing the probability that how much the image is similar to that particular class. Not top one means it give me the class ID whose probability is highest. So 999, its class ID will be 1, so it will be 1. Top 1 confidence means it give me the confidence value of that particular class ID. Okay, it give me 0.998c, 0.998 probability give me. So this will be retrieve the information from the variables, from the result of the model predictions. Now result.prop.top1 give me the class ID. After using class ID, I can easily get the class name, and using this, I can easily get the confidence. Now I have to see image. See, I have read the image in a CB2 format. You all know that CB2 basically read the image into the in the BGR format. So I have to convert that from BGR into RGB. So I have converting here. So set title class name and the confidence we are showing. So now let me run this cell so that we can see the result, the model which is trained on 5 epoch. How much it's working good. Daisy, Dandelion, Daisy, Dandelion. It's not quite, we can say we did not get any particular information that what is the actual or what is predicted. So let me show you how we can do it. Actual, our actual will be folder name which we have selected random. Image folder will be our actual one, and This one will be are predicted. Okay. Now let me run this, sir. Now it's more clear that how our prediction is going on with the model. Oh, this line will not come. This will come for the new line. See. Now let me see how our prediction is going on with the model which is trained in 5 epoch. This is one wrong. Two. Means among 16 images, two predictions are wrong. Now let me upload the model which is trained on 30 epochs and see the result of that model. Let me come back to when the model get uploaded. Okay. So the model is uploaded. The model which is trained on 30 epoch. Let me show you the result of that model. Let me see how many predictions are wrong. Okay. 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 This is wrong. One. Means among 16 images, only one predictions are wrong. Okay. It's pretty good when the model which is trained on 5 epoch. So this way you can either increase the epoch value, or you can either increase the data augmentation, and this way you can increase the accuracy also, or decrease the loss. So this is the explanation. If you this is this explanation, so please like, share and subscribe. Thanks to all.